Welcome to our journey through the cosmos, where we explore the strangest signals ever. Tonight we're tuning our cosmic radio dials to frequencies that have baffled, intrigued, and sometimes even alarmed the brightest minds on our planet. Imagine, if you will, the universe as a vast, dark ocean, and we on our tiny shore occasionally receive messages in bottles, cryptic, powerful, and hinting at phenomena far beyond our everyday comprehension. These aren't just random static, these are structured, sometimes repeating, bursts of energy that make us question our place in the universe and whether we're truly alone. From fleeting whispers that last mere milliseconds yet outshine entire galaxies to peculiar dimming patterns of distant stars that defy conventional explanation, the universe is constantly speaking to us. The challenge, of course, lies in interpreting this cosmic language. Are these the natural, albeit extreme, workings of physics we are yet to fully understand? Or could some of these signals be something more? Perhaps the unintended byproducts of advanced civilizations, or dare we speculate, deliberate beacons? It's a profound question, one that sits at the heart of our quest for knowledge. Tonight we'll delve into some of the most compelling cases. We'll examine the evidence, explore the theories, and ponder the implications of these extraordinary cosmic events. So buckle up your curiosity, open your mind, and prepare to confront the profound mysteries that these unbelievable signals from outer space present. The universe has stories to tell, and we're here to listen, to learn, and to wonder. Let's begin our exploration into the great unknown, where every new signal could be the one that changes everything. Let's transport ourselves back to August 15th, 1977. The Cold War was in full swing, disco was on the radio, and at Ohio State University's Big Ear radio telescope, something truly extraordinary happened. Astronomer Jerry R. Ehman was routinely sifting through data printouts from the telescope's survey of the skies, part of the search for extraterrestrial intelligence, or SETI. Suddenly his eyes caught a sequence of characters so unusual, so potent, that he circled it in red ink and famously scrawled, "Wow!" in the margin. This wasn't just a blip, it was a powerful, narrow-band radio signal, lasting a full 72 seconds, originating from the direction of the constellation Sagittarius. What made the WOW signal so compelling, and why does it still resonate with us today? Well, consider its characteristics. It was incredibly strong, at times over 30 times louder than the background cosmic noise. Its frequency, around 1,420 megahertz, is significant because that's the hydrogen line, a fundamental frequency in the universe, a sort of cosmic water cooler, where many scientists speculate an alien civilization might choose to broadcast, thinking other scientifically literate beings would be listening there. Furthermore, the signal's profile, rising and falling over 72 seconds, perfectly matched what you'd expect if a fixed extraterrestrial source drifted through the Big Ear's limited field of view as the Earth rotated. It ticked all the boxes for a potential alien beacon, despite numerous attempts to redetect it from the same patch of sky. The WOW signal has never been heard again. This silence is in itself deeply perplexing. Was it a one-off transmission? A glitch from an unknown natural phenomenon? Or perhaps a message from a civilization that has since moved on or ceased to exist? The WOW signal remains a tantalizing anomaly, a singular, powerful whisper from the cosmos that perfectly fit our expectations for an alien signal, yet offered no encore. It serves as a profound reminder of the universe's capacity to surprise us and the enduring mystery of whether we are its sole sentient observers. Now let's fast forward to a more recent cosmic puzzle: fast radio bursts, or FRBs. Imagine, if you will, an explosion of radio waves so intense that for a few thousandths of a second it can outshine hundreds of millions of suns. Yet these colossal bursts of energy arrive at Earth as fleeting whispers, detected only by our most sensitive radio telescopes. First spotted in 2007, FRBs are one of the hottest topics in astrophysics today, precisely because their origins are so profoundly mysterious. They come from distant galaxies billions of light years away, meaning the events that cause them must be cataclysmically powerful. What could possibly generate such mind-boggling energies in such short timescales? The list of potential culprits reads like a who's who of extreme cosmic phenomena. Some scientists propose they originate from magnetars, which are neutron stars with incredibly powerful magnetic fields. Think a star the size of a city, but with a magnetic field a quadrillion times stronger than Earth's. Others suggest colliding black holes or neutron stars, or perhaps even the final gasps of evaporating primordial black holes. The truth is, we just don't know. Each new FRB detection adds another piece to the puzzle, but the complete picture remains elusive, shrouded in the vast distances of intergalactic space. What makes FRBs particularly baffling is that some of them repeat, while most appear to be one-off events. This dichotomy complicates our models. Do repeating FRBs and non-repeating ones have different origins? Or are they perhaps the same phenomenon viewed under different conditions or at different stages of their evolution? The distances involved also mean we're seeing these events as they happened billions of years ago. We're looking back in cosmic time, witnessing ancient cataclysms. Unlocking the secret of FRBs isn't just about understanding a new type of celestial event. It's about probing the most extreme physics in the universe and potentially uncovering new laws that govern the cosmos. Every great mystery has a beginning, a patient zero that first alerts us to something new and strange. For fast radio bursts, that pivotal moment came in 2007, thanks to astronomer Duncan Lorimer and his student David Narkovich. They weren't even looking for FRBs, they were sifting through archival data from the Parkes Radio Telescope in Australia, searching for pulsars. Imagine their surprise when, amidst the familiar tick-tock of known pulsars, they stumbled upon a signal of immense power, lasting less than 5 milliseconds, originating from far outside our Milky Way galaxy in the direction of the Small Magellanic Cloud. This was the first FRB, now famously known as the Lorimer Burst, or FRB 010724. The discovery was initially met with considerable skepticism. Could it be terrestrial interference? A glitch in the telescope's equipment? These are always the first questions scientists ask when faced with something unprecedented. The signal was so brief, so powerful, and so unlike anything seen before that it took years of meticulous verification to confirm its astrophysical nature. One key piece of evidence was its dispersion measure. As radio waves travel through the plasma of intergalactic space, lower frequencies are slowed down more than higher frequencies. The Lorimer burst showed a significant dispersion, indicating it had traveled a vast cosmic distance far beyond our own galaxy, confirming it was a genuine celestial event. The Lorimer burst didn't just reveal a new astronomical phenomenon, it opened up an entirely new field of research. It was like finding a new type of particle in a particle accelerator. Suddenly there's a whole new realm to explore. Its discovery prompted astronomers worldwide to re-examine old data and to design new surveys specifically to hunt for these enigmatic signals. Without that serendipitous find by Lorimer and Narkovich, the hundreds of FRBs we know today might still be lurking undetected in the cosmic static. It's a testament to how sometimes the greatest discoveries are made when you're looking for something else entirely, reminding us of the universe's endless capacity for surprise. Black holes, the universe's ultimate gravitational monsters, are often thought of as silent abysses, devouring everything, even light. But the regions around black holes, particularly supermassive ones at the centers of galaxies, are anything but quiet. These cosmic behemoths are often surrounded by vast swirling structures of gas and dust called accretion disks. As material spirals inwards, heated to millions of degrees by friction and immense gravitational forces, it can emit incredibly bright radiation across the entire electromagnetic spectrum, including powerful radio signals. These aren't necessarily messages, but they are signals telling us about the extreme physics at play. Some of the most intriguing signals from the vicinity of black holes are known as quasi-periodic oscillations, or QPOs. Imagine the accretion disk as a turbulent, churning whirlpool. QPOs are rhythmic variations in the brightness of the X-rays and sometimes radio waves emitted from these disks. They can occur on timescales ranging from milliseconds to hours, and their regularity suggests some underlying physical clockwork near the black hole's event horizon, the point of no return. Scientists theorize these oscillations could be caused by clumps of hot gas orbiting close to the black hole. or perhaps by warps and waves propagating through the disk itself, almost like ripples in a pond, but a pond heated to unimaginable temperatures and governed by relativistic gravity. Decoding these QPOs is like listening to the heartbeat of a black hole's environment. The frequencies of these oscillations are thought to be related to the black hole's mass and spin, offering us a unique way to probe these fundamental properties. Furthermore, sometimes black holes don't just accrete matter, they launch colossal jets of plasma at near light speed, extending for thousands, even millions of light years. These jets are also powerful sources of radio waves. While not signals in the communicative sense, the complex structures and emissions from black hole systems are rich with information, cosmic broadcasts detailing the most extreme gravitational environments the universe has to offer, constantly challenging our understanding of physics. Let's turn our attention to a star that has caused more than a little cosmic consternation. KIC 84628552, more affectionately known as Tabby's star or Boyajian star, after Tabitha Boyajian, the lead author of its discovery paper. This seemingly ordinary F-type main sequence star, about 1,470 light-years away in the constellation Cygnus, exhibited a light-dimming pattern so bizarre, so unlike anything seen before, that it sent astronomers scrambling for explanations. Data from the Kepler Space Telescope showed its brightness dipping erratically, sometimes by as much as a staggering 22%. For context, a Jupiter-sized planet passing in front of a star like this would dim its light by only about 1%. The dimming events were not only deep but also irregular in their timing and duration. Some lasted for days, others for weeks. This ruled out typical explanations like orbiting planets or normal stellar variability. So, what could cause such profound and chaotic drops in starlight? Scientists proposed a swarm of comets or planetary debris, perhaps from a catastrophic collision. While this could explain some of the dimming, the sheer amount of material required and the persistence of the dimming over years made even this natural explanation a bit of a stretch for some. The data just didn't neatly fit any conventional astrophysical model. This is where the speculation, and let's be clear, it is speculation, got really interesting. One of the more exotic hypotheses, and one that certainly captured the public imagination, was the idea of an alien megastructure like a Dyson swarm, a vast collection of solar collectors built by an advanced civilization to harness the star's energy. Such a structure, if incomplete or composed of many individual, irregularly orbiting components, could indeed produce the strange light curve observed. While subsequent studies have leaned towards more natural, albeit still unusual, explanations involving dust, the mystery of Tabby's star forced us to consider all possibilities, however improbable, and highlighted how much we still have to learn about the diverse phenomena the universe can cook up. Our exploration of these unbelievable signals from outer space reveals a universe far more dynamic, complex, and mysterious than we might have ever imagined. From the singular, potent wow signal that still echoes with the possibility of an alien hello to the furious, fleeting fast radio bursts that challenge our understanding of extreme physics, each anomaly pushes the boundaries of our knowledge. The rhythmic whispers from black hole environments and the perplexing dimming of Tabby's star further remind us that the cosmos is filled with phenomena that defy easy explanation, constantly inviting us to look closer and think deeper. These cosmic puzzles are not just academic curiosities. They are fundamental to our understanding of the universe and our place within it. Each strange signal is a breadcrumb, potentially leading to new physics, new types of celestial objects, or just maybe evidence that we are not alone. The quest to decode these messages is a testament to human ingenuity and our insatiable curiosity. It requires sophisticated instruments, collaborative international efforts, and minds open to the truly unexpected. The universe is under no obligation to make sense to us, but we as a species are driven to make sense of it. So, as we continue to point our telescopes towards the heavens, listening intently for the next cosmic whisper or shout, remember that we are still in the very early days of this grand exploration. What other unbelievable signals are out there waiting to be discovered? What new mysteries will tomorrow's observations unveil? The adventure is far from over. Thanks for joining us on this cosmic adventure. Stay curious and keep looking up.